Hello everyone. We are going to go through our science presentation for this week. This is our first unit on weather. We'll be doing another weather unit next week as well. So some of the things we're going to cover this week are precipitation, clouds, erosion, temperature, wind speed, relative humidity, and how to collect and analyze data to make predictions about the weather in the future. So we're going to start in the atmosphere. There we've talked about the biosphere, the hydrosphere, the lithosphere, and the atmosphere, and we're going to dive deeper into the atmosphere specifically. And the most important layer that I want you to remember is the troposphere, and that is the layer that extends as high as 60,000 feet. Here we see it here as well. This graph is showing us that it extends as far as 7 kilometers, 60,000 feet, and the characteristics of the troposphere is that this is where most weather happens. That's a very important fact for you to know, that this is where in the troposphere where most weather happens. So weather systems are in this area. As we've said last week, as you go higher into the atmosphere, it gets colder, temperature goes down, and this is where 80% of the atmosphere's mass exists in the troposphere. So I'll send this link over to parents. We watched this video in class if you want to watch it again. All right, we talked about precipitation, a very important part of the water cycle, which we discussed last week. Precipitation happens after and as a product of condensation. So, just answered that one for us. What stage of the water cycle comes before precipitation? That's condensation. Where does it come from? It comes from water that has gone through the water cycle. It's evaporated, it's condensated into clouds, and then it's precipitated. And what are the different types? So, precipitation, any form of moisture which falls to earth, which includes snow, rain, hail, sleet, and here's some pictures I gave. These are my puppies when it snowed outside, hail, rain, and sleet here. Pretty easy. Okay, we're going to talk about clouds, which I think is really fun, and 4 different types of cloud in particular: cumulus, stratus, cumulonimbus, and cirrus. So cumulus are the really pretty, puffy, sometimes they're called cotton ball clouds. They're low in the atmosphere, the troposphere. Remember, we're going to be talking about the troposphere, the lowest layer of the atmosphere where most weather occurs. They are white and puffy with flat bottoms, and they can eventually turn into cumulonimbus. So that's cumulus clouds. Stratus clouds, I actually took this picture myself. I just thought this was amazing, this line of clouds right here when I was on a road trip one weekend. They are also low in the atmosphere. They are flat gray clouds that cover most of the sky. As you can see, these are kind of a draft coming in. They block direct sunlight. In the car, you could really tell a difference once you got under these clouds. Cumulonimbus are also low in the atmosphere, white and puffy with flat bottoms. Oops, and I think I shouldn't have put that in there, can turn into cumulonimbus. But basically, I think what I was trying to say here is that they're the result of cumulus. Cirrus clouds are the highest in the atmosphere and are high, wispy-looking clouds made of ice crystals. So here they are again. You can see cumulonimbus, which had the incorrect definition there, but they're very tall and they look like cumulus, but they're stacked and they go a lot higher than normal cumulus clouds. So we're not going to necessarily get to all these different ones, but we're going to look at cirrus, cumulonimbus, cumulus, and then these stratus clouds. Okay, we're going to do an experiment. If we get through our presentation on time, I have an experiment prepared for us to do with partners. So hopefully everybody can be on their best behavior and get through our notes so that we can do an experiment. I'm going to have us keep a weather journal in our bell ringer notebook, and we're going to just keep up with that throughout this week and next. and we're going to use that data to help us make some predictions and practice collecting some of this data. And then actually next week we're going to build 3 different models of tools that are used to collect weather data. So that will help us as well. Excuse me. Okay, let me get my, we've got some extra sheets here that I'm going through to make sure I'm covering everything. Great. Okay, one thing I do want to point out that I don't think we got to here at the beginning is the difference in weather and in climate. So weather is the condition of the atmosphere in a certain place at any moment. Weather is evolving constantly. And climate is the average weather of an area over a long period of time. So I just want to make sure we know the difference in this. So like I said, we're going to be building some different models of tools that helped us collect data about the weather. The first thing, I'm not sure that we'll get to make a thermometer next week, but we will get to make a couple other neat things. But temperature is something we're studying this week. It is measured with a thermometer and calibrated in various temperature scales and units of measurement. Most commonly, we know about the Celsius scale and the Fahrenheit scale, and the Kelvin scale is also sometimes used. And then I thought this was a fun little poem. 90 degrees is pretty hot, 70 degrees is pleasing, 50 degrees is getting cold, and 32 degrees is freezing. So that can help us sort of remember how to gauge what each temperature feels like. And in America, we use the Fahrenheit scale. All right, wind, I'm going to send this link along to parents and this as well so you can watch a couple videos about wind. But we know that we used a wind vane, windsock, and an anemometer to measure wind. And air flows from high pressure to low pressure. And this video right here will help you answer this question. We're going to do a little close reading activity on relative humidity in class, and you'll get to take that home with you to go back over. I wanted us to look at some weather maps because we're going to be looking at these symbols right here. So whenever you see these circles, that is indicative of a warm front. A warm front. So we see another warm front here, another warm front here. An L, that is a symbol for low pressure, and H for high pressure. So you can see here a mix. The arrows or triangles, circles indicate a warm front and triangles indicate a cool front. So you can see we've got a cool front coming south, a warm front going north in this area, and a cool front coming south here, an area of low pressure, high pressure, high pressure. And again, you can use this key up here to help you read this map, but also notice the cold air fronts coming down, warm air fronts going this way, high and low pressure. So warm, cold fronts. If it's stationary, it will stay like this. If it's moving in a certain direction, the symbol will point in that direction. And then low and high pressure. So erosion is the movement of a weathered material by gravity, wind, or water. The most important thing about erosion that I want you to remember is that it involves movement. Erosion involves movement, and I'll send over the link for the video we're going to watch about erosion. Weathering, on the other hand, is really the result of erosion. It's the breakdown of rock into smaller pieces through exposure to wind, water, heat, and cold. So because of erosion, we see weathering happening. And here are some examples. Weathered down. This is an example of erosion. Another example of erosion. And this is an example of weathering. Weathering, weathering, erosion, erosion. Okay, and this is our check for understanding that we're going to go through. All right. Thank you all for listening. I hope you enjoyed it.